Good afternoon everyone. This is the third variety of problem. We have solved two variety where the first variety was to find the unknown shear stress, or it might be the normal stress, and then the second variety was to just check if the given stress equations do satisfy the equations of equilibrium or not. Now the third variety is to find out the component of body forces. Okay, the similar way how we have solved the other two problems, we are just going to solve by first taking down the equations of equilibrium. Okay, so let us begin by writing equations of equilibrium. In the first case we had the body forces to be absent. In the second case we had the body forces, and now here we are supposed to find the body forces. Alright, so the equations are dou sigma x by dou x plus dou tau yx by dou y plus dou tau zx by dou z plus the body force x equals 0. Similarly, dou tau xy by dou x plus dou sigma y by dou y plus dou tau zy by dou z plus body force y equals 0, dou tau xz by dou x plus dou tau yz by dou y plus dou sigma z by dou z plus body force z equals 0. Alright, to begin with, let us take up sigma x. Sigma x is equal to 20x cube plus y square. We want dou sigma x by dou x. Dou sigma x by dou x equals 20 into 3. It is 60 x square plus 0. I'll just write it as 60 x square. Next, tau, see here, tau yx, that is z. Dou tau yx or xy, they are one and the same, of dou y, it is 0. Last, it is dou tau zx by dou z. What is tau zx? It is y cube. If you differentiate with respect to z, it is 0. Substituting these three into the equation 1, then we have 60x square plus 0 plus 0 plus capital X is 0. This implies body force x is equal to minus 60x square. Next, let us take up the second equation, dou tau xy by dou x. Dou tau xy by dou x. And what is the value of tau xy? It is z. If you differentiate it with x, it is 0. Next, dou sigma y by dou y. Dou sigma y by dou y. And what is the value of sigma y? Let us see. Sigma y is 30x cube. 30x cube differentiated by y is again 0. Last, dou tau zy by dou z. Let us see what is tau zy. Tau zy is x cube. X cube differentiated by z, or with respect to z, is 0. So let us substitute all the three components into equation 2. We will be left with 0 plus 0 plus 0 plus y equals 0. Therefore, the value of body force component y is 0. Last equation, dou tau xz by dou x. Dou tau xz by dou x. What is the value of tau xz? Let's see. Tau xz is y cube. Y cube differentiated with respect to x is 0. The next component is dou tau yz by dou y. Dou tau yz by dou y. Let us see what is tau yz. Tau yz is x cube. X cube differentiated with y is again 0. Last one, dou tau z by dou z. What is, sorry, dou sigma z by dou z. Sigma z is 10x square plus z square. It is 10, what is it? It is 10y square plus z square, sorry. 10y square plus z square. Dou by dou z of it. Okay, so we have 10 into 0 plus 2 times z, or 20z. Let us substitute all of these back into the third equation. So I'll be left with 0 plus 0 plus 20z plus body component capital Z is 0. Then z is equal to minus 20z. Here we have found the values of all the components of body forces. So this is the third type of problem that is going to be there. Now we have finished the first module. Let us start off with the second module.